Hi, everybody. Um, let's build on what we were talking about in class on Monday and talk about what else we could do with vectors. So the first thing we're going to talk about is multiplying vectors and what exactly that would mean, how we would do it. We're all rather comfortable with the idea of multiplying two numbers together. 4 times 5 is equal to 20. But what would it mean to multiply two vectors? Well, there's two different ways to multiply two vectors together. Um, if in the case when you are in any dimension, you can use the dot product. The thing we know about the dot product is that the answer is always a number, and it's an easy thing to do. We're going to talk about that shortly. There's one other way to multiply vectors together, and that's called using the cross product. That only works if vector u and v are both in 3 dimensions. When we take the cross product of two vectors, the answer is a vector instead of a number. Um, and it's not nearly as easy. It's something that you're going to have to memorize. And we'll talk about that in a later video. So let's first talk about a dot product. And let's say we have two vectors, vector A and vector B. They're in the same dimension. So, for example, here we have a vector A, a vector B, and we have that they are both the same dimension. They have the same number of coordinates. Then, in that case, we can multiply the two vectors using the dot product. If we do that, we get that A times B, sorry, not A times B, it's A dot B. A dot B is equal to, well, you multiply each of the pairs of coordinates together, and then you add them. So we take A1 times B1, we take A2 times B2, we take A3 times B3, and we add those pieces together. So you can see if the vectors are one-dimensional, right? Let's say we have A is just equal to A1, and B is equal to B1, just two numbers, then A dot B, it won't let me write there, then A dot B is just equal to A1 times B1. So this is just a simple generalization of regular multiplication. When we have more dimensions, 10 dimensions, you do the same thing. You multiply A1 times B1, A2 times B2, up to A10 times B10. You add those all together. That's the dot product. Like I said, pretty simple. Let's first there's a number of properties of dot products that are really important to know. The biggest of the big deals is that what happens if we multiply two vectors, a vector by itself? So if we have A dot A, well, what does that look like? That looks like A1 times A1 plus A2 times A2 plus A3 times A3 plus dot dot dot. So that's A1 squared plus A2 squared plus dot 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 plus AN squared. Now, where have we seen something like that before? If you remember when we were talking about distance, this is basically the square of the distance, right? So this is equal to the length of A squared, right? Because the length of A is the square root of that. So A dot A is equal to the length of A squared. All right, so that's one important thing to know. Some more properties that are useful. A dot B is equal to B dot A. All right, so what does that look like, right? How would we prove that? Well, A dot B, we said, was A1 B1 plus A2 B2 plus A3 B3. Well, what would B times A? B dot A be? B dot A is equal to b1a1 plus b2a2 plus b3a3. And if you look at these pairs here, each of these pairs are equal because 4 times 5 is the same as 5 times 4. Multiplication is commutative. And so the product of A dot B is the same as B dot A. All right, so I'll give you some more properties. You can check in the safety of your own home that each of these properties works. There's a distributive law. You take A dot B plus C. Instead, you could do A dot B, you could do A dot C, and you could add them together. Similarly, if you have a product, a scalar multiple of your vector A, you can bring that scalar multiple out. So CA dot B is the same as C times A dot B. And so the last property that we're going to talk about is, what about 0 dot A? Right, so this is the 0 vector. And what does the 0 vector look like? It looks like 0, comma 0, comma 0, comma dot dot dot. And the A vector is A1, A2, dot dot dot. And if we're going to multiply those things together pairwise, we get 0 times A1, 0 times A2, 0 times A3, and you get a whole bunch of zeros. You add them all together. So the dot product is 0. Right? And so a really important thing to keep in your mind is that the dot product, the answer is always a number. So even though this value right here is the 0 vector, the 0 vector dotted with any vector is equal to the number 0. All right. So why do we care about the dot product, or what does it really mean? Well, the thing about the dot product is it's useful when we're talking about geometry. It's useful when we're talking about looking at how two vectors are related. What's the angle between them? We can use the dot product to figure out what the angle is between vectors. So let's go through this, and then let's talk again for another minute about what we should think of when we think of this dot product. So we're going to let's talk about a method here about finding the angle between vectors using the dot product. So here's some formulas. And in this class, it's going to be important not just to memorize formulas, but also to remember why the formulas are correct. And so what we're going to see here is that the dot product of two vectors is going to be related to the length of the vectors times the angle, the cosine of the angle between them. So this is a statement, this first part is a statement about how to calculate A dot B if you have the length of A, the length of B, and the cosine of the angle between them. And this equation is an equation that tells us how we might calculate the angle between vectors by if we have the vectors A and B and can calculate the dot product between them. So why is this true? Well, this goes back to our friend from trigonometry, the law of cosines. So I'm going to draw a picture here. All right, my picture has vector A in it, and it has vector B in it. And what I'm going to draw in here is the vector A minus B. Right? How can you convince yourself that that's actually the vector A minus B? Remember, this is our vector A, and if this is the vector B, then negative b is the vector in the opposite direction. So a is the vector from here up to here, and if we add in negative b, then we get this other vector, a minus b, because a plus negative b, that's how we've defined a minus b. All right, so we've drawn this triangle here, and what this triangle gives us is it gives us a picture. We're trying to figure out what's this angle between a and b. Well, when you have a triangle, the law of cosine says that the length of the side opposite theta squared is equal to the length of a squared plus the length of b squared minus 2 times length a length b cosine theta. Right? This looks a lot like the Pythagorean theorem. The Pythagorean theorem would be c squared is equal to a squared plus b squared, and that happens when the angle is a right angle, and so cosine of pi over 2 is 0, and that would cancel that whole last term. But for general angle between the vectors, then this is our formula for that relates the sides of the triangles with the angle. All right, so let's now use what we wrote on the previous page about the length of something squared. Right, the length of something squared is so the length of, when we have length squared, we said this is a dot a. This is b dot b. And so what is this term? This is a minus b dotted with a minus b. Right, these are vectors. So a dot a, so then we do distribute, we get a dot a minus b dot a minus a dot b plus b dot b. Right, we're doing all the distributing. This a dot a, so we get, let me erase some of these things here. Well, maybe I can move them. Let's see. Oh, it wants me to do all of that, but I'm not going to do all of that. So this left-hand side is this expression, and the right-hand side has the a dot a and the b dot b in it. So let's subtract that from both sides. Subtract a dot a and b dot b from both sides. And what do we get? So this becomes negative b dot a minus a dot b is equal to negative 2a times b, magnitude a, magnitude b, times cosine of theta. We do one last manipulation, b dot a, that's equal to a dot b. So we have minus a dot b minus a dot b, which is equal to minus 2 a dot b is equal to minus 2 length a, length b, cosine theta. And if we divide by 2, divide both sides, negative 2, then we get this equation right up here. All right, so what did we do here? I know that was a lot of calculations. Let's step back and talk about what we did here. We said for any vector A and any vector B, they are two sides of a triangle. The third side of the triangle is a minus b, and the law of cosines gives us an equation for how the length of a, the length of b, and the length of the third side are all related. We used the properties of the dot product to extract, to expand the a minus b, the length of a minus b squared, and then we simplified both sides, divided by -2, and we found this equation. So this equation is not magical, it comes from what every triangle satisfies. All right. So once we have this equation, then what we can do is we can use that to find the angle between two vectors. So to find the angle between the vector 2, 2, -1 and 5, 3, -2, what we're going to do is we're going to calculate a dot b. So a dot b is equal to 2 times 5 plus 2 times -3 plus -1 times 2. Oops. So that's what? That's 10 minus 6 minus 2, which is 2. So that's a dot b. We also have to calculate the length of a and the length of b. So let's calculate the length of a. The length of a is the square root of 2 squared plus 2 squared plus -1 squared, which is the square root of 4 plus 4 plus 1, square root of 9, which is 3. The length of b is equal to the square root of 5 squared plus 3 squared plus 2 squared, which is the square root of 25 plus 9. 9 plus 25 is 24, plus 4, square root of 38, which doesn't simplify so nicely. So what that's telling us is that's telling us that the cosine of the angle theta is equal to 2 divided by 3 times the square root of 38. So we'd pull up our calculator or our computer program, plug this in, and use this to figure out what cosine is, what cosine of theta is, and use it to then define what the inverse cosine of both sides is. This is telling us that theta is equal to the inverse cosine of 2 over 3 square root of 38. And if we plug that into our calculator, it'll tell us that the angle between these two vectors is about 84 degrees. Right? 84 degrees, that's almost a 90-degree angle. It's almost a right angle between them. So let's talk about one last thing, which is what happens when the two vectors we have are orthogonal. All right, what does it mean for them to be orthogonal again? Remember this definition. Our two vectors are orthogonal if they have a right angle between them. So a right angle, cosine of pi over 2, cosine of 90, is always equal to 0. So no matter what the length of A is and the length of B is, we're multiplying that by 0, and we get that a dot b is equal to 0. All right, so this is probably the biggest takeaway here from this lesson, which is that two vectors are orthogonal if and only if a dot b is equal to 0. So if you take the product of two vectors, the dot product of two vectors, and you get 0, that's telling you that your two vectors are orthogonal to each other. All right, so when you take the dot product of two vectors, you're either going to get that the vectors have a positive value, a zero value, or a negative value. The dot product is either going to be positive, zero, or negative. If the value is positive, then the angle between them is between 0 and 90. If the dot product is 0, then the vectors have a 90-degree angle between each other. And if they're negative, then you have an obtuse angle between the two vectors. So that's what the dot product means in a geometric way. All right, so let's stop there, and I'll meet you shortly.